My name is Matt Craig. I teach physics and astronomy at Minnesota State University Moorhead, which is a small state university in western Minnesota. This is my sixth SciPy, I think. Seventh SciPy. And I started doing widgets at the very first SciPy I came to in 2014 and have been using them since. So I wanted to do just a real brief overview of what we've got planned for this morning. We have four presenters: me, Martin Renou, who's on the screen now, Bektas and Dafna will be joining us later on screen, but they're in the session now to help answer your questions if you have any. We have pared back a little bit what we're planning to do and what we've done in previous years because we anticipated this online format may be a little harder for us to get through as much material, but all of those notebooks are still here or still in the repository. And so what our plan is to go through the material that we're planning to cover at a fairly, hopefully, manageable pace for everybody. And if we find we've got, with some breaks sprinkled in throughout, and if we've got some time later on, we have a bunch of notebooks we can go back to. Like Mike said, if you have questions, please use Ask a Question to ask those, because it'll be a little bit easier for us to keep track of those. So once you've got the Jupyter lab open, go into notebooks and start either with the index or the introduction. I'm going to jump right into the introduction. Each of the pages has some navigation bar up at the top. Just a few quick Jupyter lab essentials in the setup, and it sounds like almost everybody has some experience with Jupyter lab, and if you didn't before the beginning of this week, you probably do now. Opening a notebook, you just double click on it. You can hide the file browser by clicking on the file browser icon or by typing Control-V if you need a little bit more room. To run a single code, push Shift and Enter. There is a play button up at the top of the toolbar, but I tend to forget that it's there. You can add multiple outputs for widgets. We'll show you that in just a little bit. So let's get started. So interactive Jupyter widgets are web browser controls that talk with Python. So the idea is to be able to write interactive notebooks with a graphical user interface, but to do all of that work in Python rather than having to do it in JavaScript. The core ipyWidgets package has a bunch of what I describe as fairly basic controls, sliders, and that kind of thing. We'll run through the full list in a little bit. Then there's several other widget libraries that have been built up over the last 3 or 4 years that we'll show you later. But as a quick introduction, let's make a slider. You see it doesn't take a ton of Python to get this done. You can set limits on the slider. And so with just a touch of Python, you get an interactive control. You can make multiple views of that control. And these are two views of the same thing. So it doesn't matter which one I drag on, they're both going to change. It's going to be convenient to have the slider displayed as we scroll down the notebook. So I'm right-clicking on that output cell and create new view for output. And that gives me another view. And I'm going to drag that over here, make it a bit smaller. So this new view thing is something that's part of Jupyter Lab, not something that's specific to not something specific to ipyWidgets. The folks who are just jumping in, I see a few messages, folks saying that they just got in here because you were stuck in the other widget session. We are 2 cells into the introduction notebook, so you are still right at the beginning. But so one of the things that's nice about widgets is that you can get their value from Python, and you can set their values from Python. Just getting this to be a really Baroque way to provide parameters or set variable values if this was the only thing that you could do. But you can write functions which will observe changes in a widget and then calculate a new value based on that change. So in here, I'm calculating the square of the slider value. This short function handle change will get called whenever I change the value of the slider widget. So and we're going to talk more about using observe and the details of what these callback functions need to look like in about 30 minutes or so. So we'll come back to this in more detail. This function is recalculate square, and to make sure that function's called, we just need to tell slider to observe the function handle change and call handle change whenever the value of the widget changes. So let's run this and then change the value of the widget. That looks reasonably close to the square of 5.6. I don't know that off the top of my head. It doesn't matter where the change comes from. So if I do slider.value equals 7, then show square again, a couple of things happened there. The slider value moved to 7 and we got a new value for square. One of the powerful things about widgets is that you can link values together. So here we are making a new widget, a float text. So this is a text box in which you can type floating point numbers. And we're going to then link the value of the slider to the value of the text box. And then to lay them out, we'll put them in a vertical box. And now as I change the slider, the text box updates. If I change the text box, slider updates. So I'm going to do a quick check here to see where we're at with questions. Okay, so Caitlin, it looks like your question is getting answered, but Martin or somebody let me know if I need to pause.
Well, it's installation issues, I guess, because some people are not getting the views for the widgets.
Okay.
But I guess it's, well, I don't know if that is the case for everyone, but some of them have a wrong version for JupyterLab.
Oh.
A version that is too old.
I see. Tell you what, can you give us a thumbs up or smiley face in the chat if things are working for you install-wise, and a thumbs down or a sad face in the chat if it's not working for you, just so we can get a quick sense of where folks are.
Oh, that's a lot of questions. It's gonna be difficult to keep at the pace.
Well, we'll just pause here. We'll let a bunch. Okay, so we got a bunch of. Okay, so it sounds like Binder is working. It sounds like for some people using Jupyter Notebook instead of Jupyter Lab is working.
So for the people who don't have it working, I would suggest using Binder if you can, and later if you want to check, if we want to take time another day to check your installation, we can do that.
Would it be helpful if I created a poll, you guys?
Oh, that'd be great. Yes.
So what do you want the questions to be?
Let's see here. Question or the options are working Jupyter Lab, working Notebook, working Binder, not working.
So, okay, sorry.
or we can just do working and not working. Is
okay. Working Sorry, because it was just the interface looked different for a second, and now it's better.
Yep.
Okay, so sorry. So say your original things, because I think we can get more granular if we need to.
Sure. So it's working lab, working notebook, working binder, not working lab, not working notebook.
Sorry, what was the third one?
Working binder, I think.
Working binder, and the fourth one?
Not working lab.
Okay, and then that's it?
And not working notebook.
I apologize if you guys can hear, if everybody can hear my cat in the background.
I think every video meeting should have either pets or children, so.
Okay. Let's see. All right, it should be up. There we go. People are voting.
So folks, for whom it's not working in lab, can you try Notebook? And if you're in Notebook, you won't be able to create the separate view like I've got here. This is a lab-only feature. But as we're working through this, you'll have the same widget will be displayed several times. So, but I'll try to be mindful of the fact that some folks might not be able to see that. Yeah, so it looks like we don't have anybody at the moment who is not working and is using the notebook. So if your lab isn't working, try using the notebook. It turns out the notebook extension installation process is easier at the moment than the lab installation, lab extension installation process.
And it looks like the Bqplot extension and the ipyvolume extension on Binder are not installed. So that is a bit problematic. But I guess if you are using Binder, you're going to be able to follow the entire tutorial, and it's not a big deal if you cannot run the Bqplot stuff right now. We can look at it later.
Yeah, we'll get the Binder environment updated later today. Okay, so I'm going to go ahead and resume. Thanks for your patience, everybody, as we work through this. Right, so we left off here. We had made a slider manually. We made a text box manually. We linked the two, and as you change one, the other changes. There is a shortcut that can be helpful in a lot of situations, or in a situation where you have some function, complicated function that you want to try to understand. And one way to do that is to look at the function interactively in some way. So x squared is not a function we might need to think about a lot, but it's a straightforward example. So the idea here is I've written this function. It doesn't know anything about widgets. There is a, I can skip that. It's not going to affect anything. A interact function of widget. You give it a couple of things. The one required thing is which function you want to interact with. And then you can give it some hints about the arguments of the function. What that generates is a slider, goes from 0 to 100. So because 0 and 100 are both integers, ipywidgets assumed that you wanted an integer slider to cover a range of numbers, and the output of the function, or the return value of the function, if there is a return value, is displayed before or below, rather, the widget. We'll talk more about interact in a couple minutes. There are going to be a few times during the tutorial where we have solutions that you can load for exercises, and I put in this exercise just to try that out. So if you want to modify, without looking at the solution, go ahead and modify the interact so that x goes from -10 to 10 instead of from 0 to 100. Or if you prefer, load the solution. There are a few steps to that. Uncomment the load line, run that cell once, and it loads the solution, and then run the cell again, and you get the solution. Notice that we got some extra output here. It says function main, whatever. It's because the representation of interact is that you can suppress that by putting a semicolon at the end. Okay, quick check for questions here. And I don't see any new ones, so I'll keep going. Yes, the question about can we interact with something other than a slider? I'll get to that in just 1 second. So behind the scenes, every widget, even a pure Python widget, is running some JavaScript. So there's a Python piece which connects to the notebook kernel. There's a JavaScript piece running in the browser, and the Jupyter notebook framework takes care of message passing between those two. Almost every widget I've written myself has been a pure Python widget. So you can do quite a bit with just Python. But there is the opportunity, I guess, if you think of JavaScript that way. I struggle with it personally sometimes. But there's possibility of writing your own JavaScript also, which gives you quite a bit of power. Okay, so let's go to the next notebook. We've got a whole list of things that we'll come to later that are packages separate from ipywidgets with more specialized or more involved widgets. So we'll come back to interact in just a moment. I wanted to take a couple minutes here at the beginning and show you an example of something you can do in pure Python. So if we all try running this, the server that we're serving this up on in my campus is going to crash. But this is a COVID dashboard that a colleague of mine was taking a computer science course over the summer, and their project for the summer was to put together a COVID dashboard with local data. I'm not going to go through any of the data in detail. The point is that this is the code for this is a Jupyter notebook. And so everything you see in here is or almost everything you see in here is a widget, and all of the code that you're seeing was written in Python. Another example is same colleague. Last summer, put together a bunch of widgets, or maybe it was 2 summers ago, a bunch of widgets for our intro astronomy course. And again, I'm not going to click to this demo, but all of the widgets, or everything that you're seeing on the screen here, was done in Python. In this COVID example, the boxes, the graphs in the orange boxes were made with ipympl, which is a widget interface to Matplotlib. The magenta box is ipyleaflet, and everything else is widgets from the regular ipywidgets. So I wanted to just give you a big picture. This is an idea of the kind of things that you can do. We're serving this notebook up with the dashboard up with Voila, which we'll talk about towards the end today. It serves up a notebook displaying just the output, essentially. So we're going to talk a little bit more about interact. And so this should answer the question from earlier about can you do more than sliders in interact? And the answer is yes. I'm going to work with a different function, one that takes your input, multiplies it by 3, And if I give a initial or a default value for the function argument, based on what value I pass in, ipyWidgets chooses what it thinks is an appropriate control. So here I passed in an integer, it generates an integer slider. If I instead pass in a Boolean as the default argument value, then ipyWidgets generates a checkbox. So at this level, which control is generated depends on the type of the argument that you pass in, although it turns out you can customize that. You don't have
Matt,
to. Yep.
Someone is asking if you could slow down a bit.
Oh, sure. Sorry about that.
Sorry to interrupt.
No, I should have. You know, it would. So I teach, and I usually remember at the beginning of every semester, in every class, to share that my favorite description that I've ever had of myself in a teaching evaluation is that I was like a hyperactive gerbil on caffeine. The shoe fits. So thanks for the reminder that I should slow down a bit. I get really excited about this stuff, and I'm drinking coffee.
Maybe you should slow down on the coffee then.
It's true. We've still got several hours. I should make the coffee last. Yeah, the slow down, speed up thing would be nice. Okay. So we're in the notebook using Interact. And had defined a function that multiplied its input by 3. And notice so far that you can change the control that's generated when you use Interact with the function by changing the default value you give for the function argument. So in our first example, that was a slider like we saw before. In the second example, the input we put in was, or the default value for X was a Boolean, so ipyWidgets generates a checkbox. We'll see a couple more examples in a moment. I just saw John's comment. Right, so we'll see a couple more examples where we just change the type of the input variable to change the control, and we'll show you briefly how you can build your own widget that represents the control. So our function takes its input, multiplies it by 3. So it turns out we can do that with a string. So if your default function value is a string, you get a string, or a text box rather, and the function value is, function return value is printed below the box. So notice in this case, let me scroll back up to the function for a moment. This function doesn't print anything. It just has a return value. And that return value is automatically displayed by Interact below the widget using an output widget, which we'll talk about in a little bit. Okay, so let's do look at some more complicated examples. So or a different example. So it's a little more complicated in that the function that we're going to talk about next has 2 arguments. And this time, to make the function interactive, instead of calling the interact function, we'll use the interact decorator from widgets. And notice that to set the function argument types, you provide 2 default value for each of the function arguments. You might ask, when do I use the function interact and when do I decorate? One answer to that question is that it depends on where the function's coming from. If the function's coming from a package where you don't have the access to the source code for the function, so you can't. Okay. Seeing there's a couple questions about define decorator. I'll do that too, as best I can. If you don't have access to the source code of the function, then you'll use the interact function because it doesn't. You don't need to modify the source code that goes with that. If you're writing the function yourself in a notebook, then you may prefer to use the decorator. There was a question about what is a decorator, and second checking my binder is checking maybe. So a decorator is essentially a function that returns a function.
It's kind of a wrapper around your function that provides meta functionality, I would say.
Yeah. The @ symbol at the beginning of a decorator is essentially a shortcut that's built into the Python language for saying call interact with the function that's below the @ decorator and return a new function to which interact has added some features. Is there anything you'd like to add to that, Martin, or is that okay for the moment?
Yeah, no, it's okay, I guess.
Yeah, if we have some more time at the end, it'd be great to talk about decorators some more. Another question about lambda. Okay, let me do a quick example here. Well, lambda is a function that you define anonymously, meaning you define it in one line. We're trying to come up with an example on the fly here. It's not going to work. So the idea with the decorator is to, like Martin was saying, to wrap a function. So let's suppose this is a excruciatingly. Yeah, you know what? Actually, I'm gonna make the judgment call to stop this part way through. And I think I'll stick with that. The decorator is. Lambdas are limited to roughly a line of code defining a function without a name. Decorator is a function that takes in a function as its argument and returns a function. Typically that same function that you put in, but with some extra features added. And we may have some examples. I think we have some examples of that later in the tutorial. I saw a question about the range of slider widgets. We'll come back to that in a moment. If you have some function arguments that you need to keep fixed, but you want other ones to be interactive, you can do that also. So here the function h just returns its 2 input values, and we fix the second parameter of the function to be 20. And left the other as a slider. So now to return to the question about how do you set the range and what control do you have over the widget that's generated, you can, if you want with interact, send in not just a default value for your argument, but a widget. So in our earlier example where we set up a slider to go with the function x, we gave it an integer value 10, and it automatically generated a int slider. Behind the scenes, what was actually generated was an int slider whose value was 10, the value we passed in, with a min of -10, max of 30, and a step of 1. So we can get the same kind of thing like this. So one way, not the easiest way, but one way you could change the range is by changing the min and the max on the int slider. This would be fairly cumbersome to type. And so there's another way to do it that's a little bit more compact. So this table tries to summarize the options you have for specifying what the slider is by choosing an appropriate default value, short of doing this whole define a widget in detail. So if you put in true or false, you get a check box. So if you put in x equals true or x equals false, if you put in x equals hi there, like we did before, you get a text box. For an int slider, you can either put in a single value, like we did earlier when we said x equals 10, or you can put in a min and a max. So if you wanted the slider to go from 0 to 10, you would say x equals parentheses 0, 10, and we'll see an example in a moment. If you want to, you can also specify a step. So if your function for some reason needs to have even numbers as its input, you could do 0, 10, 2, and you'll get a slider which steps up in steps of 2. Floating point numbers, sliders work the same way. So if we'd said x equals 10.0, we would have had a floating point slider for which you can provide a min and a max also. If you provide a list, you'll generate a drop down. I'm going to pause for a second, see. Oh, very nice. There's a little nice description of a decorator in the chat now. Check the questions.
Matt, could you just really quickly identify the questions that have been answered? So I can mark them off.
So I think the
first one is answered. How do you separate the view to a new panel? This one.
Yeah, go ahead. I'll let you handle it.
I guess it's an installation issue. I would either use Binder or Jupyter Notebook. It might be easier to use Jupyter Notebook for those who don't have a Jupyter Lab installation working. So yeah, the first one can be closed as well.
The one instead of seeing a slider, that one?
Yeah.
Okay.
And I think
yeah, go ahead, Matt. Sorry.
Can you save the value of an interact into a variable? I think we've answered. We're going to see. I think the short answer is no, but we'll see how to do that in a moment. There's another can you explain decorator question? I think we can mark as answered. I believe that Seth's question about the mechanism that makes Jupyter the widgets work in the notebook, I think, is answered too. And the question about
So the one about, can the example widget be created as an executable file? I guess I answered it. I'm not sure.
And so
you're saying that has been answered, or you're going?
Yeah, I
it has
guess.
been answered, yes.
Yeah.
Okay.
And I'll answer the question. I think we can. The one about interact upper lower bounds has been answered or will be answered in just a second. And then the rest are not answered. But
How to generate drop down? I can answer this one.
Well, I've got it up next in our notebook. So
okay, yeah, okay,
coming up soon. Okay, so let's try these out. So if I pass interact a x equals 0, 4, that should generate integers because both 0 and 4 are integers. The default step is 1. And the minimum value should be 0, works, and maximum value is 4. If you want to get floating point numbers, then pass in either a floating point value for a step, which is what I did here, or for the initial or final values. Okay, so we have a short exercise built in here. The idea is for you to make this function reverse interactive. So the function doesn't do anything super fancy, but takes a text string on input and reverses it. So take a moment to try to do that. And Jennifer's question, we'll come back to in a moment about the dropdown. There's a question about matplotlib chart. We'll come to that in a moment too. So if you can give us a thumbs up or something like that in the chat, if you either have the exercise working or are ready to move on, otherwise ready to move on from the exercise. So it looks like a lot of folks have it. Let's see if I can live code this. Oops, quotes. I've been waiting days to do that. Oh, I forgot my semicolon. Right, so I put text into the box and it gets reversed. So the interact that we've talked about also works with functions where you set a default value for the function. So here, the default value for x in this function is 5.5. So that's the value that the slider is set to. And I've used the hint up here to indicate what I want the range of the slider to be and what I want the steps to be. Someone had asked about dropdowns. If what you pass in is a list of items, then you get a dropdown. Right. I've forgotten what this f was. This function f, remember, takes its input, multiplies it by 3. It is possible with dropdowns to have a different value displayed than the value that's associated with the widget. So in this case, I've got two options on the dropdown, the word 1 and the word 2. The word 1 is associated with the value 10. The word 2 is associated with the value 20. So if I change from 1 to 2, I'm getting a numerical answer out from the function because the value that's being put into the function is a number, not the string 1 or 2. So I think that we've answered Jennifer's question about dropdowns. And I think we've answered the question about interact, allowing user to enter a, this question here about allowing the user to enter a float into a text box instead of a slide, a slider bar. Let me address that real quick. So getting ahead of myself a little bit, I think in the next notebook or the notebook after the next one, we'll look at the full list of widget controls in ipyWidgets. You'll see the list of all the options that there are, but one of those is a float. So to get this, let me explain how I got that magic. So in JupyterLab, if you're partway through typing a method name or attribute in this case, and you type tab, it'll give you a list of possible completions. So let's make a floating text with a value of 5, and I think this will work. Yep. So float text is a text box which only takes floating point values. It doesn't do anything with those values until you hit enter. But if I try typing in a word, I'm mashing my keyboard right now, and most of it's not getting in. The letter E is getting through because IV2 is shorthand for 5 times 10 to the second, so it's valid as a floating point input. So higher end. Let me quickly address the Dershan's question about interact versus at widgets.interact. They're the same.
Yeah, the question about is it possible to redraw a matplotlib chart is answered as well.
Oh, okay. Yeah, and the next example of the notebook's a basic interactive plot. So,
yeah.
Let's take a look at that. Okay, so here I've a few things. At this point, there are these 2 or 3 plotting libraries that you can use with widgets. Matplotlib is one of them. Bqplot's another one that we'll be talking about later. The easiest way to use Matplotlib with the widgets is to include this cell magic in your notebook, and that will activate the widget backend for Matplotlib, which displays the plots in the notebook as widgets. So this plot at the end of the day is plotting the equation for a straight line, y equals mx plus b. The rest of this, let's see, how much do I need to talk through? The function itself takes two inputs, the slope and the intercept, and the rest of this is doing some housekeeping, defining a figure, clearing the figure each time we call it, and displaying. So I can make this interactive. And I need to scale things down a bit so we can see it all. And then as I change the slope, the function updates. As I change the intercept, the function updates. I sometimes teach a course in cosmology where we're talking about the expansion of the universe, and some of the functions that describe how effectively the size of the universe changes over time are complicated to look at, but if you can attach some sliders to the function values, it's so much easier to explain how various properties of the universe change as you change the amount of matter. So next up is an exercise. Oops. So the exercise was to make a plot that plots the function f of x is sine kx minus p, and I wrote the plot function for you. The intent was that you were going to make it interactive, but it looks like I was jumped ahead of myself and put the solution in there. So I'll just run this. Yeah, so this is an example where if I'm teaching physics, algebra-based physics, say, where most of the students have used trigonometric functions, but they are not intuitive for the students. I find it particularly difficult sometimes to explain what the phase of a sine function or cosine function means, and having them be able to interact with it and change the value of the set phase and watch how watch how the curve shifts, lets them put into words what it does without me having to try to do it for them. So there are many, many examples in the ipywidgets repository of using interactive with some more complicated use cases. I'm going to take a quick check here for questions. Short answer is sliders stay, but the plot disappears. So is this, I assume this is the problem some people are seeing? Yeah, so there's a couple ways to fix this. One is, so what's happening here is that, so if you're having this problem where you rerun the cell and the sliders are gone, the issue is that I'm setting the matplotlib figure number here, and once you've destroyed that figure, widgets can't, or the notebook can't display it anymore. When you rerun the cell, you're destroying the widget. Any more questions? About Interact before we move on? Oh, thank you. So part of the reason we're going to talk about Bqplot is that it's, I was going to say a little more robust, but it may just be I'm more familiar with using Bqplot in the context of widgets. But Bqplot was designed from the beginning to work with widgets, and it's got a native was built from the beginning on widgets. So using it with widgets is sometimes a little bit more straightforward. What's nice about the Matplotlib solution is that many of us already know how to use Matplotlib, and so getting the widget interface is just a matter of using the %matplotlib widget. Okay, so in the interest of time, I'm going to skip this notebook that has more about Interact. There are going to be several notebooks like this where we have optional up at the top. And we're about 10 minutes from a break. Okay, so much of this we've talked through at least a little bit. But as a reminder from after our Interact interlude, all of the controls you've been seeing, so the last 15, 20 minutes in Interact, you have access to underneath the hood and can get their values. Interact is not the only way to make or to use widgets, but in some instances, it's a really convenient way to do it without having to write a lot of widget code yourself. There's two ways you can display widgets. One is if the widget itself is the last entry in a cell, it's displayed. Or you can use the display function to display the widget. And as we saw before, you can have multiple views of the same widget, and they're tied. It's not just that they're tied to each other. In the underlying JavaScript, there's one model that's representing the state of that widget, and each of the views is a new view into that model, but they're all looking at the same model. So they always have the same value. So one of the things nice about working with widgets is that there are a lot of conventions that make it easy to figure out how to use a widget you haven't used before. So one of those is that almost every widget has a value. There are a couple of exceptions. And as you change the value of the widget, you get in the user interface, you can get the value out programmatically, or you can set it programmatically. There's a way to find out what keys or what those, what other properties you can get from a widget by using the keys property. I find this really handy because I can never remember what all of these are. Some widgets have a max and a min, like a slider has a max and min, that makes sense. A text widget that's displaying a string doesn't have a min and a max because that doesn't make a whole lot of sense. And so it's useful to be able to see which attributes a particular widget has. You can set any of these attributes like description or description tooltip either after you've created the widget or at the time that you create the widget. So I can create a widget setting the value to hello world and but starting it as disabled like this. This is equivalent to first creating the widget and then setting each of these values individually. I forgot to display the widgets. So either way. We saw briefly before that you can link two widgets. And so here I'm linking a float and a text. Any change in one updates the other. And you can unlink them. Once I've unlinked, changing the slider doesn't change the text box, and vice versa. So in some cases, link is all you need to wire up a bunch of widgets that are connected to each other, like the COVID dashboard that we looked at before. Much of that is the drop downs and stuff are connected to each other with link. The other mechanism for connecting widgets or doing something based on their a change in one of them is to use observe. In the example we had in the very first notebook, we had a slider and a function that calculated the square of a value. In that first notebook, the square wasn't displayed on the screen, which is a little bit of a hassle. You had to type the name of the variable square into a notebook cell and run it. Here I'm using the same input, a slider, and now displaying the square underneath. Let me talk through the bits of this. Slider is the same as the one we saw before: minimum, a maximum, and a step, and it's a floating point. The easiest way to display text, particularly if it's a block of text rather than just a very short label, is with the HTML widget. And so here I'm defining that HTML widget. I've made a function which will eventually get called every time the slider changes. When the slider changes, I'm going to update the HTML widget to hold the value of the square of the number that I put in. Next, I tell the slider that it needs to observe the function update square display, and it should only watch for changes in the value of the slider, not in the description or in the min or max or any of those other keys that could change. And then for display purposes, I'll put both of those into a vertical box. And now that we're at the bottom of this notebook, I'm taking a quick look through the questions. Okay, so I'm going to start at the bottom of the question list. There's a question about, is there a difference between link and JS link? Yes, and we'll come back to that in the events notebook in about 20 minutes. I think the question about the output or the buttons next to the output plot has been answered. Yeah. And I hope Scott's question about the interactive plot not showing up has been resolved. And there's another question in there about the interactive plot that, oh, okay, it hasn't been resolved. I'll tell you what, Scott, I'm just going to start the next notebook, and then we'll take a break. And during that break, I'm happy to work with folks to try to get their interactive plots working. Okay, so I want to move on to the next notebook, which has a list of all of the widgets in the core ipyWidgets package, and we'll look at the first couple cells of these and then take like 10-minute break, and I can help people try to resolve issues during that time, or run and get yourself some more coffee, or just stretch. Okay, so the core ipyWidgets package has a bunch of widgets in it. We used to just have a long list of these in the notebook. Instead, we've arranged the list of widgets into a widget. So the display here, when you run the cell, should look something like this. The widgets are organized by their, in this particular view, by their interface. You can see there's a bunch of different float widgets, or slider widgets rather. For floating points, you have widgets that represent a range instead of, will let you select a range instead of just a single value. For any of these, you can get more detailed help by clicking on the name of the widget. This will open up a separate notebook and take you to an example that shows you some of the values you can set in the widget, although it's not exhaustive. So let's pause here for a break, and we'll resume again in 10 minutes at 10:20. And so go ahead, Martin.
No, I just unmute.
Oh, okay. Yes, we'll take a short break. If you're still having issues, we'll try to do some troubleshooting with you here during the break.
So for those having issues concerning the plot, it might be related to ipympl. So either your lab extension for ipympl is not installed, or the installation is broken, or maybe your JupyterLab version is not correct. If you're using JupyterLab 1, it might not work. So please check that you have JupyterLab 2. And yeah. But it's not a big deal. You'll be able to follow the rest of the tutorial, even though.
Sorry, I didn't mean to interrupt you, Martin, but I just saw Scott's message that he tried it in a different browser and it worked.
Oh, if you are using Internet Explorer, you actually should not, because actually Matplotlib ipympl doesn't work in Internet Explorer. So that may be another reason for it to not work.
Karen, you could probably, if you... Okay, I think I have an idea here for... So just import the sleep function from time and run the cell with sleep, or run the cell with sleep in it, and that will have the kernel active, so it'll seem like you're still active. I'm pretty sure. I wouldn't use, rely on that if I had Nobel Prize winning work in in the binder, but that may do the trick.
So if you're trying to change from Matplotlib widget to Matplotlib inline, be sure to restart the kernel, otherwise it might not work.
So Mike, I think you can mark the question by Ty as when using interact, is there a way to capture the user's input value as answered?
Are ipyWidgets usable in panel? Yes, you have panel widgets, I think.
Yeah, I thought I heard in a talk or tutorial earlier this week that the panel widgets
Yeah, they support
support ipyWidgets now.
I don't know if it's a full support, but it might support some of it.
Mike, we can mark the do decorators allow for a function to exist and act only on the interactive you paired with it. I think I've answered that now. Henry is saying that in Safari, the date picker is not working. I haven't run into that myself, but it's one of the challenges of doing anything in a browser is the of doing anything in a browser is that different browsers behave differently. So if you could report that issue in ipyWidgets, that would be helpful. Ty was, okay, let me take a look here, Ty, real quick. Yeah, so Ty, your question about the value question, Jason Grout suggested that one approach is you declare a global variable in, or you declare a variable outside the function, declare it as global in the function, and you can get it that way. Depending on what you want to do, it may be the case that you don't want to use interact. There's a better way to do it, and then you'll have a little more control over passing values back and forth. Okay, we've got an answer to Safari. Got another minute till we'll restart. Amanda had a question about for the y equals mx plus b widget. Can you change the graph so it has a thicker line on the x equals 0 and y equals 0 line? Yeah, we could. I think the way I would do that is in Matplotlib is use h-line or h-lines to draw the line along y equals 0 and v-line or v-lines to draw the line, draw an additional line at x equals 0. But as far as I know, you'd have to manually draw those lines. I don't know of a way to automatically make them appear. So I think we can mark that one as. Okay, so it's 10:20. So Martin, what I'm thinking is that we'll do the first exercise in this notebook, and then in the interest of time, let's move on to events. And we've got some more exercises in this widget list notebook that people can try later, or we can come back to if we have time towards the end.
Yeah, sure.
Okay. So, so I'd encourage you to explore when you have a chance more of the widgets that are available. As a short exercise here, it turns out that there's something broken in this very first example that we did. And I was careful when I showed this not to demonstrate the error. So first, it looks like this is great. I type something, grab the slider, the value in the text box changes. I set the value in the text box and the slider changes. Whoops. But if I set a value in the float text that is larger than the slider value, the slider stops at 10 because the maximum value we gave for the slider was 10, the minimum was 5. Okay, so I realize I'm making you play a little bit of hide and seek here, but the fix to this is to use a different text, float text thing than float text. So take a look in the list above, find the one that seems like the right one to use, and change it. So I'll give you a moment to try to do that. What you want to do is change it so that you've got a text box here, which is also limited to 5 on the low end, 10 on the high end. So let's see. Looking at this, it looks like bounded float text is promising, but let me check. Yeah, I can give that a min and a max. So of course, I can't remember whether it was float text bounded or bounded float text, but I think the bounded was at the beginning. And let's see here. I want the min to be the same as the slider. So instead of putting in 5, I'll use slider.min. I want the max to be the same, so I'll use slider.max. I guess I don't need to worry about the value because I'm going to link the values. So let's see what happens now. Okay, so my first check, have I broken the slider to box direction of the linking? Nope, that still looks good. Now what happens if I try to put in 100? Notice that what happens, so here, let me put in a longer number here. When I hit enter, whatever I've typed in is going to get reduced to the maximum value. If I try typing in something negative, it's going to get the text, bounded float text will set the value to the minimum value. All right, so I'm okay, so there are a couple of questions about the file upload widget. We'll try to get answers to those a little bit later. But I think we're ready to move on to your section, Martin.
Okay.
So let me stop sharing. Mehmet, if you can say something in the chat, please, then Mike can pull you up onto the screen and I'll drop off. So Mehmet's going to be going after Martin. I will drop myself off. Well, I think I can drop myself off.
So can you all see my screen? Can you say in the chat if you see my screen? Yeah, okay. Thanks. So I realized I did not introduce myself at the beginning. So my name is Martin. I'm a software engineer at Quantstack, which is a small company originally based in Paris, but we have an office in Berlin now. And we mostly do work around the Jupyter ecosystem. And myself, I've been working on interactive widgets since 2 years and having a lot of fun on it. So I'm going to show you widget events. So widget events are really useful. That's, I think, the most important thing to remember from this tutorial is widget events. So in order to use events, ipyWidgets is based on Troubleshooting, which is a Python library which provides a hashtrace class, which itself provides properties validation and observation. So for example, if I create an identity class inheriting from hash traits, from traitlets, I can, for example, define a username property and an age property. And this username property is validated by type. It must be a Unicode value. And the age property is also validated by type. It must be an integer. And using traitlets, you can actually validate values as well. So for example, if I want to validate the age to be between 0 and 115, I can do it. So ipyWidgets is totally based on this. So when you use a slider, actually the slider value, the int slider value, for example, is an integer, and its value is validated by type and by value. So let's define this and create an instance of identity. So I can dynamically change the attributes. So if I change it to 54, that works. If I change it to -2, it will trigger the validation, and of course it will fail because it must be in this range. And if I set it to be a string, for example, it will fail as well because it's not the right type. Traitlets. So as I said, traitlets provides validation and observation. So it provides a method called observe that you could see before. And the way it works is that observe, you can pass a callback and you can tell which properties you want to observe. So for example, on my identity instance that I have here, if I want to observe the age property, I just need to call the observe method and provide the function I want to call when it changes. And the function here, it must take one argument, which is a dictionary, and this dictionary will contain all the information about the change. So if I change the value here and print the change, it will show me the dictionary. So the dictionary contains the name of the property that has changed, the old value, the new value, and the owner of the property, which is in our case, Jane. So as I said before, ipyWidgets is based on traitlets. So every ipyWidget class is actually a hash trait class. So it has an observe method. So all widgets you will see have an observe method, and you can observe properties, and you can bind callbacks that will be called when the properties change. How is it on the base? Should I speed up, or is it good? Okay. So here I've got a small example having a label widget and a slider widget. And what I want to do, so the default value for my label is start moving the slider. Check on here. So this is my label and this is my slider. And what I want to do, I want to observe the changes on the value of the slider. And I want to call this function, which will update the label value. And it will update it with the slider value is negative or positive, depending on the slider value. So if I move the slider, it will update the label. So you can use observe to make your widgets interact together, and to not only make your widgets interact together, but if you move your slider and want to start a new computation given the slider value, you can implement your observe method that will start the computation given this slider value. So that's pretty handy. Concerning the signature, so as I said before, it takes a change argument, which is a dictionary. So I can look at the values in the dictionary. So, for example, the old value and the new value, and I can print them, for example, here. The old value was 44 and is now 40. So why would you use observe instead of link? Link is very useful when you want to link two widgets values together and they need to have exactly the same value. You can actually do that with observe as well, but observe is very useful when you need to apply a transformation on the value. So for example, I'm printing here two widgets. The first one is a temperature in Celsius degrees, and the second one a temperature in Fahrenheit degrees. And I want to link those two values, but I want to, when this one changes, I want to update the Fahrenheit value by computing it before updating this value. So what I do here, I've got, so those are two float text widgets. And when the Celsius degrees float text changes, I want to call this function, which will update the Fahrenheit value by calling this function here, C to F, Celsius to Fahrenheit, given the new value of the widget. So this works. If I change the Celsius value, it will correctly call this function and update the Fahrenheit value. But this doesn't work because I did not set up the observe on this widget in order to update this one. So as an exercise, I will, so let's give you a couple of minutes to fill this callback function and to set up the observe yourself. So maybe we can make a poll for when people are done or not, and I can maybe answer questions during that time. So why the output is cleared on each change? This was done thanks to this. I'm using clear output wait true. So clear output will clear the output widget. But if I call it without wait true, it won't wait for a new output to come in order to clear. So if I don't have wait true, I can show it to you, it will flicker a lot. That's because it doesn't wait for the new output value to come in order to update the value. So if I do wait true, it waits and it doesn't flicker anymore. So this was thanks to the clear output. So one person is finished. Why not use link on the last example? Do you mean this one, the exercise? So you can do string formatting, I think so, at least. You can do string formatting on a slider readout, but I don't know for the value inside of the box. I'm not sure. Okay, should I see someone voted for still working, hold on. Should I hold on a bit longer, maybe? So the change new syntax, okay. So when you when the callback is triggered, it's triggered with this change dictionary. As I showed before, this dictionary, it contains the name of the property that has changed, the old value of the property, the new value of the property. So when I get the value like that, I'm actually taking the old value from the dictionary in this one, in this variable, if that was the question. Okay, so let's give you the result. So in this callback, I want to compute the Celsius value given the new Fahrenheit value. So I'm going to use F2C because the Fahrenheit value changed and I want to compute the Celsius value. And I want to take the new Fahrenheit value from the text input. And in order to set up the observe, what I want to do, I want to observe the Fahrenheit value. So I do this. And I want to call on fchange when it changes. So if you execute that, then updating this should update the Celsius value. Okay. So advanced linking. Matt showed you how to use link to link two widget values together. So if I use two sliders here and I use link on them for the values, then the two sliders values should stay the same. But you can actually use a d-link, which is a directional link. So this takes the first argument, which is the target or property, the source property, sorry, and the second argument is the target property. So for a directional link, if I move the source property, it will update the target, but if I move the target, it doesn't update the source because it's directional. And concerning links, when you create a link, you get out a link variable, same for the link, and you can use unlink to break the link. And you have two other ways of linking, which are JSLink and JSD-link. So those are done on the JavaScript side. So it's done on the web page. So if I do a JSLink between two sliders, those sliders are linked on the web page. While if I use link, it's actually on the Python side that we are linking the two values. So this is, first it's interesting because I don't have a lag when I update the slider. This one updates way faster than when I use the link because it doesn't go through the Python kernel to link the two values and send the new messages to the JavaScript side to update the values. So it's actually faster. And another thing is that if you export your widgets to a static page, for example, in the documentation, you can find this exact notebook in the documentation. But in this documentation, I don't have a Python kernel running on the server. So the link that I did here doesn't work anymore. This is because I don't have a Python kernel that will update the slider 2 value if I update the slider 1 value manually. But the JS link still works because the link is done on the web page directly. So JS link is very useful when you want to embed your widgets in a static web page, and you have a JSD link, which is just like the directional link Python side, but it's done JavaScript side. and you can unlink them as well. So, any question on the links? Yeah, you can play Doom in Jupyter. Actually, there is a Doom widget by Wolf, which who is one of my colleagues from Quantstack. He was streaming the game view inside of the notebook, so it was, I guess, kind of hacky, but it was working. It was nice. So now continuous versus delayed updates. So some of the widgets have a continuous update attribute, and this allows you. So here I've got an example with an int slider with a continuous update equals false. So what it means that when I grab the slider and I start moving it, it won't send any message to the kernel. Well, it actually does, but it won't, because I linked this slider to other widgets, it won't update them until I ungrab it. Okay, so I don't have a continuous update on the other widgets. And if you set continuous update to true, which is actually the default value, then it will smoothly update all other widgets. Continuous update equals false is actually very useful when you want, for example, to trigger a computation when you change the slider value. You want to start a new computation given the new slider value, but this computation may take time sometimes. So you don't want to trigger it 20 times when you move the slider. You just want to trigger it for the last value of the slider when you ungrab it. So it's very convenient in this case. And finally, some widgets like button have special events. So the button widget has a non-click event, which allows you to bind a callback function that will be called when the button is clicked. So the button widget is actually a stateless widget. You don't have a clicked state. You only have a non-click event. So the way you use it is by creating your button, and you do button on click, and you pass the callback function that you want to call when the button is clicked. So here what I print button clicked. So if I click, it works. So I guess that's it for me. You have lots of optional notebooks concerning widget events. Those are exercises that you could do on your side if you have time, but we won't go through them today. And I guess I leave the board to Mehmet, who will show you how to do styling of widgets and how to do layouting, which is pretty nice. I guess I can look at questions before that. Any reason to use link over JS link? Jason says link is probably a bit simpler to reason about. Yeah. I guess using JS link is actually better in most cases, but yeah, that's up to you. If you want to embed your widgets in a static web page where you don't have a Python kernel on the server, then using JS link is important. It's also important to know that JS link will work, but all the observe, because when you use observe, you pass a callback function that is in Python. And if you don't have a Python kernel living then on the server, then the observe callback cannot be executed. So all the observe callbacks won't be called if you use embedded widgets in a static web page without a Python kernel living. So at the end of the tutorial, I will explain to you how to extract your widgets in a static web page and how to do dashboarding with widgets while still having a Python kernel living, so still having the observe function working. I did not look at the questions here, sorry. So can I have multiple observe assigned to the same attributes? Yes, you can do that. And how to control the order of execution? I don't think you can actually. Jason, if you're still in the room, maybe you know the answer of this question, but I don't think you can control the order of execution of the observe callbacks. Widgets can trigger the observe. Yes, of course.
Are you done? Am I good to go?
Yeah, please go ahead. Yeah.
All right, thanks you, Martin. Hi, everyone. My name is Mehmet Bektas. I work at Bloomberg and I contribute to several projects in Jupyter ecosystem. And today I will walk you through layout and styling features available in Jupyter notebooks. These are especially important if you are building dashboards or rich applications using Jupyter notebooks. And let me share my screen. I guess everybody can see my screen now.
Yes, we can.
All right. First, I will start with I will talk about the basics of layout and styling of widgets. Then we will go over some container layout widgets available in Jupyter widgets. Let's start with layout and styling of the widgets. Right. Every Jupyter widget has two attributes to control layout and styling of the widget. They are named layout and style as expected. Layout attribute lets you control size, border, and placements of a widget within its container. And style attribute lets you control styling of particular aspects of a widget. And style attribute is specific to each individual widget type. Layout and style attributes both expose CSS properties of widgets. CSS basically defines how elements are displayed on a web page, and widget attributes, layout and style, provide a way to customize these visual properties. And here is a list of CSS properties exposed through the layout property. And these map directly to CSS properties, except underscores are replaced with dashes. And you can see there's an extensive list of all the properties here. Let me scroll down. And here we have an example of a layout. In this cell, we are creating a button with this layout properties. Layout attribute is a object of type layout. Here, our button covers 50% width of its container size, and it has a height of 80 pixels, and it has a border of 2 pixels dotted and blue. The values of the CSS attributes follow the CSS specification. So if you have any questions, you can look up in the CSS specification. For example, border here is specified with the width first, then style and the color. And for the length units, you have different options in CSS. You can use percentage, you can use pixels, or you can use EM or other units available based on your layout needs. And layout objects of a widget can be shared among multiple widgets, and they can be assigned to other widgets directly so that you can have same look and feel across multiple widgets. Here we are creating another button and we are reusing the layout of the first widget. And you can later on access the layout property and make changes to it, and their changes will be reflected to view immediately. Here we are changing the width to 30%. And here we have a style example. As I mentioned, style attribute is specific to each widget type. Here we are creating a button with a button style, and we are assigning a color of light green. The names of styles attributes don't necessarily match to CSS properties, but their values follow the CSS specification. And similar to layout, style attributes also can be accessed later on, and then they can be changed. We are converting the color to yellow. And if you want to see the list of available styles for a particular widget, you can look up the list, style.keys. And here we can see the styles available to a button. They are button color and font weight. And just like the layout attribute, we can assign a style to another widget, and then you can have the same look and feel. Let me check the chat. Any questions? Is the pace good for everyone? All right, I'll continue. And here's another example of style. We have a slider here, and we are changing the handle color of the style. Again, this handle color is specific. Okay, here's a question. Can you pass a style sheet? Yeah, you can. You can customize Jupyter Notebook. That's one way, and you can create, for example, HTML widgets, and you can specify CSS in there in your HTML widget. And you also need to assign classes to widgets so that they are picked by the particular widget if you are using a style sheet. Okay, maybe a little slower. Sure. Okay, another question from Anar, style of the notebook. You can control those by creating a theme. You can theme Jupyter Lab or you can theme Jupyter Notebook. You can look up those, and there are tutorials for those. And we have a notebook here which lists all the styles available for each particular widget type. And you can use this as a reference if you want to style the widgets. And one other thing to mention before we move on to the details of layout, we also have button style and bar style attributes available for some of the widgets. And these are the widgets listed here that have these attributes. And these can have values from a list of options, and these options are success, info, warning, and danger. And for button style, you can also have primary. These can affect more than one aspect of a widget. For example, they can be changing the background color and the text color of a widget. These are quick ways to style the widgets. And these are also theme aware. So if you switch between light theme and dark theme, they will blend with the colors of the theme nicely. And now about the container layout widgets. When you create dashboards or rich web applications, you will have many widgets on your UI, and you will want to arrange and align them in a particular way to create a user-friendly UI. And CSS comes with great tools to help you with the layouts you want to design. And two of these are Flexbox CSS layout and Grid CSS layout. Flexbox CSS layout lets you lay out widgets in a single direction, in horizontal direction or vertical direction, or rows or columns, you can say. And Grid CSS lets you lay out widgets in 2 dimensions as cells of a grid. Your widgets can cover one cell or a range of cells. And Jupyter Widget exposes these layouts through a series of container widgets. For the Flexbox CSS layout based widgets are box, hbox, and vbox. And grid CSS layout based widgets are gridbox, 2x2 layout, app layout, and grid spec layout. And box is the base container for Flexbox layout. Hbox gives you a horizontal Flexbox layout, and vbox gives you a vertical Flexbox layout. And the gridbox is the generic lower level grid layout, and 2x2 layout just gives you a layout with 2 columns and 2 rows. App layout gives you application-like layout with header, footer, and sidebars and the central content area. And grid spec layout lets you easily create an n by n grid layout. Before I continue, let me check. What is CSS again, please? CSS basically defines how elements are rendered on a web page. It controls the layout, the positioning of the items, and also the styles, the colors, and so on. All right, here we have a detailed reading material. Please go through this on your own, and there are links to very nice tutorials about Flexbox and grid layouts, and also links to MDN, Mozilla Developer Network, for detailed documentation of these layouts. And here is the detailed documentation about Flexbox layout. I will skip this and I will move on to examples. All right, here we have a vertical Flexbox example. We have 4 buttons created here using these labels, and they have button style danger, as I mentioned earlier. And these buttons have a layout assigned with auto, with width setting set to auto. This lets them to expand to the size available in their container. And vbox here, the virtual Flexbox, which is created from a box, is their container. And it has a style of layout width of 50%, which covers the 50% of its container. And FlexFlow is columns, which means align the items vertically, and align out items is set to stretch so that it expands the items inside to the available width. And there are additional styles. And here's another example. We have a horizontal Flexbox created using hbox, and it has 3 buttons, and these buttons have the width assigned to them based on their weights, proportional to their weights. And for example, this total length is divided into 5 pieces, and 3 pieces of length is given to the middle button, and 1 length of the pieces were given to the ends. And this is controlled by the flex property of the layout. Flex is a shorthand property which defines as the first parameter, it is the flex grow, second one is flex shrink, and the last one is flex basis. Flex grow means expand this widget at this weight once more room is available. So that's why the middle element, middle button, is getting 3 portions of the share. All right, another example with the combination of horizontal Flexbox and vertical Flexbox. We have 2 columns here, which are vertical Flexbox, vboxes, 2 vboxes with 2 buttons in them. And they are inside the hbox container, so that they are side to side. And we can later on access the elements, the children in the container, and change their properties. So we are setting first button to blue color, and we can go ahead and update the items, the children of a box itself. So we are updating the content of the second vertical box with 4 new buttons. And we can use these properties of the layout to change the arrangement of the buttons or widgets within the boxes. So if we use column reverse in the second box, then items will be ordered in the reverse order. And for the left box, left vertical box, if we change the justify content, items will be aligned to the end of the container, end of the box. And if we change it justify content to space between, what it does is it flushes the first item and the last item to the end, and then it distributes the space in between. And since we have only 2 elements, they just end up at the ends. And you can set the flex parameter of the layout to define the flex growth, to set how it uses the remaining area. If you set only one of them to 1, then it will cover the remaining area. If you set the second item to the same value, then they will share the space equally. All right, we have another example here with a form. Let me change the width to a higher value. All right, we have a form here, which is a VBox, which is a vertical flex box, and it has 4 items in it. These are the items in it, form items. And these items are each H boxes, and each H box has 2 widgets, which is a label on the left, and it has a widget on the right. And you can see that they already look fine when you put the widgets into a box in Jupyter Widgets, because the Jupyter Widgets come with nice default values for their sizes. And notice here for the HBox rows, we are using form item layout, and their justify content is set to space between. This lets them to go to the ends of the form to have a nice look. For example, if you had flex start instead, they would be left aligned within the HBox. So just space between is a nice setting in here. And also our VBox here is using align item stretch, which means expand the rows so that they cover the full width. If you had flex start there, they would be left aligned, for example. And here is another example. If you wanted to create a toolbar-like widget, you could create the buttons of the toolbar as regular buttons. We have 3 buttons here, and we have a status check on the right. And normally you would want to align this status check to the right. You must have seen, even in Jupyter Notebook, you can see we have status on the right. You can achieve this by combining 2 HBoxes. You can have an outer HBox, and you can put the tools buttons to another HBox, and then status can be another widget inside the outer HBox. And if you set the justify content to space between for the outer HBox, they would be flushed to the ends, and you will achieve the look you want. And here is another example of how you can achieve this. You could instead use a spacer label element in between the buttons and the status check, and that would expand the label thanks to the flex parameter set to 1. It will cover all the remaining area, and then your status check would be appearing at the end. Let me stop here and check if there are any questions. Everything good with the pace and all that? All right, I assume that's a yes. All right, let's combine the toolbar and the form. This might be a app look you may want to have. We can combine them to a VBox, but by default they don't look so nice because the width of the form is not 100% like the width of the toolbar. So we can change the width of the form to 100%, and the border of the form is not looking nice anymore. We can remove it. Instead, we can put the border to the outer container to make them look together. And then we can add some padding to the outer container to make it look nicer. So you can see by changing these parameters, you can make a lot of changes to the layout and achieve the final look you want to have in your application. All right, this is another example. This is a carousel example. Carousel itself is made up of buttons with heights 100 pixels and the minimum width of 40 pixels. and they have a button style warning, which makes it orange color. And there's 40 buttons here, and they are put inside the H box to get this carousel. We are setting overflow X property to scroll so that any items that are outside of the view can be viewed by scrolling. If scroll was set to hidden, overflow was set to hidden, sorry, then you wouldn't be able to see those elements on the right. And we have a absolute width here for the container. And the carousel and the label, scroll horizontally here, is put in a V box to put them in separate rows. All right, this tutorial comes with a very nice widget to explore different layout options in Flex layout. You can change the parameters here. You can experiment with it and see the effect in the display area here. And this also generates the Python code that is needed to get this layout. And you can use this tool and copy this code into your own notebook in order to get the same layout. Please spend time on this later on and see how the parameters are affecting the layout. And here we have two exercises. Please spend like 3-4 minutes on these, and then we will move on to grid layout. All right, we have a question from Theodore. Can the carousel auto-scroll on mouse over? You need to actually scroll. I guess you could add an event listener for mouse over, and then you can maybe manually scroll it, but I'm not sure if you can change the scroll position of a widget. That may not be exposed. In plain HTML, you can do that using JavaScript, but in Jupyter widgets, there may be a limitation on the scrolling position, controlling the scrolling position. Yes, as Matt mentioned, this is contributed by ipyleaflet using the layout exploring tool here. All right, let me see. Okay. Okay, in the first exercise, for align items, please use column layout. That will make it easier. Since all the buttons have the same height, using row layout makes it more difficult. All right, I think I will continue with the answers to save time. In the first one, we are asked to change the order of the items. So if you just change flex column to flex float to column reverse, then your buttons will be ordered in the reverse order. In the second one, we are asked to change the float to row. Just pass in row here for the flex flow. You will see that items are now in a row. Width is not good enough to display all the items. We can change it to 40% width. And in the third one, we are asked to experiment with align items. So I'm going back to column, and then let's change the align items to flex start, which will move items flush to the left. And then we can do flex end. And we can do center for the align items. And the other question here is aligning items into rows. If you make the width shorter, you expect them to align, but for that you need to use the wrap mode with your flex flow. Flex flow is a shorthand for flex direction as the first value and flex wrap as the second value. So if you need to use wrap for items to be wrapped to another row. And here is the second exercise. We are asked to change the minimum width of the first item in the carousel. Let's make it 80 pixels. Default is 40. So you notice that they are all updated. This is because we are sharing the same layout object, because all the buttons are assigned the item layout here. So when we change one value, it is affecting all the buttons. So in order to have a single specific width for the first one, let's revert the width, we need to create a new layout object for this first button. And we can do it like this easily. Let's make the width 80 pixels. And we are also asked to set the height to 100 pixels. Oh, sorry, use a different height. Pixels. So by creating a specific layout for the first item, we can achieve that. All right, let's see if there are any questions before we move to grid layout. All right, here's some additional reading material, details about the grid CSS layout with links to very nice tutorials again. Please read this on your own. I will move on to examples. Here in the cell, we create some widgets to use in the layout, and we have a helper function to create a button. We will use it in the layout examples. And here's an example of 2x2 layout container. This is a very simple layout widget. You define top left, top right, bottom left, and bottom right widgets, and then it puts in 2 rows and 2 columns as expected. You don't have to specify all of them. If there's any remaining, if any slots are not defined, then the layout will configure itself and merge the cells to cover the remaining area. If you don't want that behavior, you can set the merge to false, and then it will keep that unassigned area empty. And similarly, you can access the widgets in the layout later on, and you can change their properties. Let's change the style of bottom right widget. And you can later on add widgets or change widgets in the layout by accessing them through the properties. And you can set the spacing of the rows and columns by using the grid gap property. If you specify one value, it will be used for row spacing and column spacing. If you provide 2 values, the first one will be used for row spacing and second one will be used for the column spacing. And here is another example using Bqplot. Here we create a 2x2 layout again. We don't specify the top right widget, so that the bottom right widget, which is a plot, is covering the whole right area. And there are slider widgets which are linked to the plot, so that you can interact with the plot here. So very simply, you can create a app-like layout here. And here's another layout. We have another high-level layout, which is up layout. We are creating widgets to use in the layout here, and then in the cell we are creating the layout itself. So up layout has 3 rows. It has 2 header and footer rows that span 3 columns, and it has a left sidebar area and the right sidebar area, and it has a central content area. You don't have to have all of those in the layout. If you don't want to have any of them, you can set them to none when you create the layout Here we don't have a footer in this layout. And in this layout, we don't have a right sidebar. And this one doesn't have a left sidebar. And this one has no sidebars. And similar to all other layouts we have, this is very easily customizable. You can set the sizes of the rows and columns easily. Here, this is the default layout. And you can set the width of the columns by using pane width property. You can send down a list of sizes. If we are setting the width of the left sidebar to 200 pixels, and we are using fractions for the right, you can specify floating numbers, or you can use the string notation here. These are the same. These two are the same. Fraction means distribute the remaining widths proportional to their fractions. So this remaining width is divided into 4 chunks, and then 3 are given to the central area, the middle column, and 1 is given to the right sidebar area. Similar to the columns, you can size the rows, you can use pane heights, then that will set the header area to 50 pixels, and it will distribute the height proportional to their weights for the middle row and the footer row. And you can also access the properties of the widgets in the layout and change them. And you could actually specify these sizes when you created the widget in the first place. Like this. Any questions for me? All right, and the next one is grid spec layout. This is a widget with following an API similar to Matplotlib's grid spec. It is a very convenient way of creating M by N grid of widgets. Here we are creating a grid layout with 4 rows and 3 columns, as seen here. And we are assigning widgets to the cells of this grid very conveniently using the index notation here. And your widgets can cover spans, ranges of rows and columns. And for that, you can use the slice notation of the layout. In this example, widget 1 is covering rows from 0 to 3, excluding 3. So 0, 1, 2. And it is covering columns from 1 to n. And similarly, widget 2 here is covering all the rows, and it is covering column 0. And you can continue using the index notation to access the widgets in your layout. And you can replace the widgets in your layout using index notation, and you can also use you can continue using slice notation to cover ranges of columns and rows. And if you want to change the property within a range, you can specify just one cell within that range of rows and columns. And we have another example here for the grid spec layout. We have a dashboard of plots. We use Bqplot. We have a 3x3 grid spec layout here. And we have histograms, bar charts, and scatter plots here nicely laid out. And here is a grid box example. This is a lower level way of creating a grid layout. We create here 3 rows and 3 columns. We specify the sizes of the rows and columns using grid template rows and grid template columns. We put the sizes in here with separating by spaces. So the columns are, for example, 100 pixel width first one, 50 pixel width second one, and 100 pixels width the last one. And we also define grid gap, 5 pixels for the rows and 10 pixels for the columns. Here we have an exercise. Please spend 1 or 2 minutes on this. It's asking you to add more buttons to this layout and see how it is displayed in the layout. Look through questions.
Matt, are you okay with taking a break at this point? Matt has suggested maybe we take 5 to 10 minutes.
Sure, I will continue. I have very few items left. I could finish those up as well.
So, Matt, would you rather wait until he's done and then take a break between speakers, or what?
I have only one more item left. I think better to finish.
Okay.
All right, let me continue with the answers to this exercise. Let's increase the number of buttons to 19, for example. And you will notice that they are not following the same pattern, because there's a special property for that, which is called grid auto rows. If you want to have new rows have specific sizes, you can use it. You can set, for example, grid auto rows to 40 pixels, then all the new rows will be set to 40 pixel height. If you want them to have the same pattern as the original 3 rows, then you need to use the same settings as the original 3 rows. And let's paste it here, and now you see newly added rows are following the pattern. And there's another way to define the grid layout, which is using grid template areas. Here, you specify your cells using some unique names, and those define how widgets will cover the areas in the grid. For example, here we have a header that is spanning 4 columns and single row, and we have a main area spanning 2 columns, and there's a blank area specified by using dot, and then we have a sidebar on the right. And we have similarly, we have a footer spanning 4 columns and single row at the bottom. And for widgets to go into the right positions, you need to set the grid area for each widget in this layout in their layout specification. You can see the widgets were created using the proper grid areas. And here we have an exercise. Please spend 1 minute on this. We are asked to add another row or 2 to the area. So the main area is 3 rows high and 2 columns wide. It's currently 1 row high and 2 columns wide. After this exercise, we will be done, and we can have a break. All right, let me continue with the answer. You will be tempted to create another row in the template areas. And once you do that, you will see it's not working, and you would think maybe you need to add a template row for that. Let's try doing it. It still doesn't work because of the size auto. Then you can switch to use fractions for the sizes, and you will see that this one will work. Now our main area is 2 rows height. So instead of doing this, we could actually directly set a higher fraction for the middle row. This would be a quicker solution. And this is all I have about grid layout, the layout and styling of the widgets actually. And the next will be Itai. He will talk about more widget libraries. Let's have a break now, and I can answer questions during the break.
How long do we want the break to be for?
We originally planned for 5 minutes.
Maybe we can take 10 because people are having some installation issues. We're going to try and help them before we progress.
Yeah, makes sense. Let's do 10 minutes break. All right, 10 minutes. We go through the questions. Okay, several folks are reporting Bqplot is not working in Binder.
Yeah, it seems like the Jupyter Lab installation, plugin installation process doesn't complete there for some reason. So yes, it won't render for you in Binder. If you are in a position to try and run the Conda installations from scratch, we have done so yesterday and they worked. If you are in a position to try that and let us know, it probably will take around 10 minutes for you to finish everything, but it might fix the issue. Also, in some folks were using Internet Explorer and Safari, and it's probably best if you use Chrome because this is the browser that has most is the most compatible with the widgets. And yeah, let's take it from there.
Another user, Jennifer, is reporting Bqplot is not working locally. If you follow the instructions using Conda environment, everything was supposed to work just fine.
Yeah, I will add that in the installation instructions, there are two sections that we need to follow. The first one is to just create the Conda environment, activate it, and then install a kernel spec. But if you scroll down, there are additional instructions where you need to actually install the Jupyter Lab extensions. And that part is actually further down the README file, but it's still required. So it is possible that you have run the Conda installation, but forgot to run the Jupyter Lab extension installation command. So if you can try that and let us know.
Okay, Martin is saying that you need to downgrade to 0.12.12 for Bqplot. There must be an incompatibility in the latest one. Okay. Okay, we are not locking the Jupyter Lab extension installed for Bqplot to a specific version, so it's pulling the latest version, and that has a problem. Yes, as Kelvin suggested, please restart your kernel after reinstalling the package. because that's only when Python changes are picked up. You may want to, yes, as Marktan suggested, refresh the page. That will pick up the latest JavaScript changes. So please refresh the page and restart your kernel when you reinstall Bqplot. And by the way, there's plenty of additional material about layout and styling. We didn't cover everything here. Please go through those notebooks yourself. They are about specific styling available for certain widgets, and a notebook on widget label styling. And there are also additional exercises available for widget layout.
Would it be possible to add a poll to see how people are doing with the Bqplot installation issues? And whether people are still experiencing problems after the fix we suggested?
Yes, absolutely.
That's a good idea.
What do you want?
I guess it could ask just for if they have Bqplot working now or not. What do you think, Itai?
Yeah, whether Bqplot, so first option is Bqplot working. Second option is, have you tried running the suggested fix if it's not? And I guess the second option already includes Bqplot not working.
I think it can be Bqplot working, first one. Second one, I tried the installation instructions. Third one, it's not working.
Yeah.
Or I don't know. Third one, I didn't try his instructions. That means it's not working too. It's hard to put in a single poll. Okay, nice.
Right.
A lot of people are now reporting that Bqplot is working now. Everyone, please try to use the poll to vote for if Bqplot is working for you.
Yeah, Andrew, yes. This when you install or update the Jupyter Lab extension, it has to rebuild Jupyter Lab as a whole, so it might take a while.
Those who haven't tried the instructions yet, please do so. They are in the chat. we have only 30 votes and 80% says Bqplot is working for them.
Okay, I guess it is working for the majority of the users. So perhaps we can proceed with the presentation.
All right. Thanks, everyone. Now I will pass on to Itai.
Thank you, Mehmet.
All right.
Hi, everyone. Just let me check everything is set up. My name is Itai Dafna. I am a software engineer at Bloomberg. I have been involved with widgets from early on as a user in my previous role. And recently I've become more involved as a developer. I contribute to a number of the widgets libraries that we have covered and that you will see in my part of the presentation. And I'm very excited to be here today. For some reason, Mehmet, you might need to stop sharing because I can't share my screen. Is this visible to everyone? Can everyone see my screen? Fantastic. Okay. I will zoom in a little bit. Okay. So I will be talking about more widget libraries. Some of you may not be aware, but the Jupyter widget ecosystem actually has a well-defined protocol for sending and receiving signals, which allows you to create more elaborate, more advanced widget libraries. So ipyWidgets is probably the most basic one, which gives you basic controls which map to the browser's native APIs. But you can get a lot more sophisticated if you want. You can have various plotting libraries, mapping, 3D projection, etc. There are many custom widget libraries that leverage this ecosystem. If you are feeling adventurous and you want to try building or authoring your own custom widget library, there are some excellent tutorials written here, one of them by the QuantStack team, who are heavily involved in the Jupyter ecosystem and widgets in general. And there are some cookie cutters to get you up and running quickly. They do require, if you are looking to author your own widget, you do need to know a bit of JavaScript, but I think it's a worthwhile investment if there is something that you're interested in having which doesn't exist yet. Some of the libraries I will cover here today are ipyleaflet, which is a mapping package for displaying interactive maps, pythreejs, which is for 3D rendering, Bqplot, which we're all familiar with now. It's a 2D plotting library based on D3, and ipyvolume, which is an additional 3D plotting libraries. In previous years, in previous iterations of this tutorial, we covered a lot more, but due to the nature of how this year's SciPy conference is delivered, we have reduced it to just a core 4, but there is an additional widget libraries directory here, which has a few more examples from previous tutorials that we've covered. So if you're interested, if you see what you like and you're interested in exploring further, please do give those notebooks a look, because they are awesome. So check permissions. Okay. So the first widget library I will talk about is ipyleaflet. It's a leaflet.js bridge. So if you are not familiar with leaflet.js, it is a very popular JavaScript library for interactive mapping, probably the most popular one if you are in the space of mapping. And ipyleaflet gives you Jupyter bindings to it, so you can use widgets to create and control maps without knowing the JavaScript side of leaflet.js. So I'm going to import all the usual suspects. Here I am just setting some default properties for the map widget, which I will instantiate in the next cell. It's just coordinates as to where do we want the map to start and how zoomed in we want it to be. So we start with the map widget. The map widget is the most basic widget that you can have in ipyleaflet. Think of it as like a canvas. You start with a map. Looks like that. And then you can start adding layers on top of that. As you'd expect, it is a widget. Like any other widget, you can access and modify its properties. So if I want to make this map a bit bigger and change its height, I can do so. There are many additional layers that you can add on top of a map in ipyleaflet. In this particular example here, I am changing the base layer, which is what you're seeing here at the top, to satellite imagery. Now, you probably noticed that I've already scrolled away from the map, so you can't really see anything that have any changes. So this is probably not the most ideal way of using this widget. So a trick that you will be familiar with by now is creating an additional widget view for your output. So we can follow that and we can sort of then drag it to the side. But probably an easier way where you don't have to right click and rearrange is to use Jupyter Lab Sidecar. This is only available in Jupyter Lab. What it does is that just allows you to programmatically create that window on the right-hand side. And you have this nice tabbed view here. Essentially the same functionality as right-clicking and generating an additional output window, but done programmatically. So now I can continue executing my code without having to scroll up and down to see any changes reflected. So I have changed the base layer here using some satellite imagery, and I am now adding a slider to effectively say, okay, from which day do I want these images to be displayed? So we're looking from 30 days ago up until yesterday. And these images can be heavy to download, so it might take a while for them to reflect on my map, but you can see that as I'm adjusting the date on my slider, the map reflects those changes with those images. Very cool. Okay, so we're going to add our first layer, and the first layer is a marker. It's a normal Jupyter widget, and there are two main methods for you to add a marker or a control to your ipyleaflet map. This is an interesting syntax where you sort of append something to the map, but there is another way of doing that, which I will show further down this notebook. So we're just going to add this marker to the map, and you can see I have this marker here that I can drag. The idea behind a marker is to specify and highlight points of interest on the map. It is a widget, so as you'd expect, it has properties that you can display and modify. You can add interaction. So I can add this interaction here that allows me to control the opacity of the marker. However, a marker on its own typically means that you have something to click on. So just like you would in something like Google Maps, you would typically have some sort of marker here that you will click on, and then either a HTML pop-up or something of the sorts will appear. And that's exactly what we're doing here. The difference is, because these are all widgets, you get to enjoy the rich interactivity and cross-functionality that the ipyWidgets system offers, the Jupyter widgets, excuse me. So in this cell here, I'm creating a float slider, which should be familiar by now from the earlier portion of the tutorial today. And I am linking the value property of that slider to the mark property of my marker. Sorry, to the opacity property of my marker, and then I effectively set the pop-up property of the marker to be equal to that of the slider. And then when I click, I now have, it's a bit too large, okay? I now have this slider here. This can be anything. It doesn't have to be a slider. It's just a simple example to illustrate what you could do. But if you wanted to put a Bqplot chart in there, you can. So this can be as simple or as sophisticated as you'd like. Just let me see if there are any questions. Okay. Is the pacing okay? I guess this poll might be a bit stale by now. Okay, great. So you can imagine a use case where you have a lot of these markers scattered all over your map. It can get quite difficult to look at because you have a lot of them and it obscures or maybe takes away from the aesthetics of the map, especially as you zoom out. This is where marker clusters come in. So we're just going to create some random markers here, and I will then create a marker cluster for them, and I will add that marker cluster to the map as a layer. You can see, let's move that one out. These marker clusters are all in this area, and I can either click on them and it will zoom in and sort of show me in greater detail where they are, and I can, if I want to zoom further, I can do that, and then I have them fully displayed. So the idea here is that it allows you to cluster them together if it makes sense, so that it doesn't litter or make the map quite heavy with markers scattered all over the place. So a really nice feature, and it sort of lumps them, it clusters them together as you zoom out and breaks them into smaller pieces as you zoom in. Another layer that you can add is a heat map. So I'm just going to import the relevant widgets here. Again, I'm setting some properties, just coordinates and the zoom level for the map. This is a helper function that creates random data, which will allow me to define the shape of the heat map. In this cell, I am now changing the center and property a center and zoom properties of the map that I have on the right hand side here to be those new coordinates that I specified. So the map will now take us to a different place. And I will now render the heat map. I'm creating a new heat map widget here, and I will render it and add it. You see here I'm adding it as an add layer instead of doing your m plus equals whatever I need. We're just doing add layer. That's another way of adding the your layers. Okay, so this is my heat map. I will now use create a button. And that button has a callback, an event listener. Whenever I click it, it will execute this generate function, and the generate function will then use my create random data helper function to change the shape of this heat map. I could click on this all day. It's very satisfying to watch. Another example, again, using the rich cross functionality of the Jupyter widget ecosystem, I can create an int slider and then link the property, the value property of that slider to the radius property of my heat map. And as you can imagine, this will let me either increase the radius or decrease it. Another thing that you can do with ipyleaflet is controls. And in this cell here, I have two layers that I will be creating. One we'll call left layer, and the other one we'll call right layer. And I will create this split map control widget, which, as you can guess, due to the very intuitive naming, will allow me to split the map into two parts and compare the layers. This is one of the coolest features in ipyleaflet, in my opinion. Just a small interjection here. ipyleaflet is fully compatible with Jupyter Lab CSS variables. So if you are a fan of dark mode, like myself, you would want to use Jupyter Lab's dark mode whenever you can. ipyleaflet makes it easy to use because it will adapt its own theme based on the Jupyter Lab theme that you have. This is done for free out of the box. So if you were to write your own custom widget, Jupyter Lab custom theme, this should also work for you with your theme. Okay, I'll remove that. Let me check. Yeah, it is a very neat feature. So another thing that we can add are widget controls, and I'll let you guess. Guess what a widget control is. You can add any widget as a control to your map. So here we're going to create a button. Again, we love our buttons, and there is a callback that we will specify, which will instantaneously transport us to NYC. Great business idea. And we're going to assign the on-click callback to this button. So whenever we click it, the map coordinates will then change to display NYC. We're gonna create a widget control out of this. So that's an important step, and then add that widget control. So notice in the widget control section here, I'm just specifying that the widget control that I want to add is this button that we have created above. And there's also a position argument here as to where do you want this to be displayed. And add that, and the go to NYC button appeared. And I warn you, it's a very interesting aerial image of New York. It would be very hard to guess if you didn't know that you're looking at Manhattan. But there you have it. The button worked. I did mention Jupyter Lab theme support. So this is a this is a pretty advanced example. So if you haven't run these notebooks before, which I wouldn't expect you to, it is unlikely that this will work out of the box. So if you are interested in exploring this further, ping me once this tutorial is over, and I'm happy to help you to walk you through the installation and setup of these of the required configuration. So there are additional installations here like the netcdf 4 and the xarray package, and also getting this wind data, which we will display. Okay, so we are using familiar patterns. Again, we are setting some default values for the map. Notice I'm creating a new map here. So M2, and I'm also creating a new sidecar. So I'm going to create an additional view to the one that I have currently displayed, which will display that map. And I can now click on it, and you can see that I have a nice dark theme map over here. So I hope you're ready. This is probably one of the coolest examples that I have to show today. This, if you are into data of streams like wind streams, oceans, this is your example. So we're going to add this velocity layer here. Look at that. Very cool. Okay, I will close these two because we're not using these two maps in the next example. Another advanced example is ingestion and usage of GeoJSON data. GeoJSON files are purpose-built JSON files. They contain the coordinates of various polygons, so they can describe countries, states, cities, and they can also bundle data payload with the coordinates of those of the different locations that they describe. So we're going to create a new map here. We're going to load a GeoJSON file that I have available locally, and we will create a GeoJSON widget from that and add that GeoJSON layer to our map. So I'm going to talk about the rest of the example in this cell in a tiny bit. I just want to give you a demo. So this example may be familiar if you have, well, it will be familiar because I think Matt was showing a somewhat similar version of it earlier this morning, but really the version that I'm showing here is adapted directly from the Leaflet.js website. So there's a JavaScript example, shows you how to recreate this using native JavaScript. What I have here is the ipyleaflet version, which in my opinion is probably a lot easier and more straightforward to work with because of the nature of writing Python code versus JavaScript. So what we're seeing, these are different states described by the GeoJSON file, and they carry a population density per square mile data for each of these states. And based on the GeoJSON, ipyleaflet can then knows and it can draw and apply styling depending on the value that each of these polygons here carries. So it renders these states, it adds an event listener for a hover. As you can see, I'm hovering, I'm not really clicking. And each time there's a hover event, this HTML tile in the top right corner here updates with the data for that state. So how does this work? To start with, we have a normal ipywidget HTML widget, which just allows you to display simple HTML, nothing sophisticated. We have a widget control, and we have a update HTML callback that then takes the values from whenever a callback is executed. We are passing data to it to then render in the HTML file. So depending on my hover action, it reads from the GeoJSON, passes the GeoJSON data to update HTML, and update HTML on hover, as you can see here, which is the event listener, just executes that function and updates my tile. Check. Yeah, thank you, Martin, for... Yes, Andrea, this is something that there is an example in here. Let me just check. Are you using you are using the wind stream data. Yes, this will not work if you are not running these commands here separately. We didn't preload them because they might take a while to download, and we didn't want to bloat the installation with additional packages that are just necessary, like netcdf4, which are necessary specifically for this demo. But yes, if you can run these commands outside Jupyter and make sure this command here effectively gets you the wind data that you're looking for. You will also need to install Xarray, which is not really mentioned anywhere here, but it is necessary, and then it will work. So we have an exercise. So how about you take 5 minutes to do this, and we can then move on to the next JIT library. Okay, let's do this together. So I'll create a map, my map, to map. This might be a bit, of course I need to display it. That's not helpful if I don't. The default zoom levels might be a bit funny. I haven't really specified them, but as I zoom out, you can see that we are somewhere in Africa. Okay, so we have the map, create a slider controlling the zoom level. Let's start with creating the slider. So my slider is a bit called int slider. Now we want to control the zoom level of the map, so I'm going to have a minimum. I'm going to put a max of, let's say, 10 and a value to start with of 5. Okay, so we need to control with a slider. That means we need a link. So the first one will be the my slider and the value property. The second element will be my map zoom. Now I also need to display my slider. And that seems to be working. Okay, embed the slider in a widget control. So the hint here is a widget control. My control is a widget control. The widget is my slider. The position is bottom left. We need to embed it. So it's my map plus equals my control. There we have it. Much nicer when it's actually displayed within the map. Okay, and that is ipyleaflet. There are lots of many awesome examples, additional examples that you can find in the repo of ipyleaflet. So I highly recommend that you go and check them out if you're hungry for more. And without further ado, I will now move on to Pythreejs. So if you ever liked 3D and you want to render 3D in your Jupyter in your Jupyter notebook, Three.js is definitely a contender. It's one of the earlier Jupyter widget libraries, so additional, I would say, more advanced Jupyter widget libraries together with Bqplot. It's based on WebGL, so you can get GPU acceleration out of the box for free. Originally authored by Jason. Jason is a colleague at Bloomberg. I believe he's in the audience with you in the chat. So if you have any questions, if he's still there, he might be able to help. And Vidar, who is a developer, who's the main maintainer nowadays of this package. I don't think Vidar is in the chat today. Notice that it says that pythreejs is not a 3D plotting library, as in like it only exposes the 3JS scene and objects to the Jupyter kernel. And that is true because to really make use of pythreejs, you actually do have to know a bit about how 3JS works, and in general about meshing, shaders, cameras, scenes, and renderers. So it is very low level in that regard. But always, as always, low level typically translates to very flexible too. So you can actually create very cool 3D projections with it. And these are all widgets. So the scene, the camera, the renderer, and my mesh here, which represents the ball, these are all widgets. So you still get to, enjoy all the benefits of having these as widgets, because you can access and modify the properties from the notebook. So I can change the size of my mesh. Here is a low-level animation using a for loop in Python. Typically, we have widgets for that with like a play button and pause, but we're doing it simply with a simple for loop here. Again, another way of showing you how you can use everything. A clickable surface. So a clickable surface, as the name suggests, will render you here a surface. Yes, this example is quite verbose. So again, low level, there is a lot of code that you need to write in order to make sure that you get the exact output that you expect. This is some sort of saddle, right, that you can see here, and I can double click, and then you can see that I have some callback events, which then in this particular case, they don't do anything sophisticated, but just give me the coordinates of that I clicked on. And you can change the Z-axis and the angle if you want. And this is an example where we're actually taking a raw JavaScript function written in as presented as a string, and we then pass it on to another widget which can read it and then render it on the front end. So again, not something I would expect users to know from the beginning, because it is very low level, but nevertheless, it's nice to know that you can have this kind of capability if you need it. And that is it for pythreejs. Let me just check if there are any questions. Okay. Looks like we are in good form. Next is Bqplot. Bqplot is, you will be familiar with from our shenanigans earlier this morning. It is one of the first and most comprehensive 2D plotting libraries that was designed specifically with the Jupyter ecosystem in mind. It was incubated and developed in its early days by the quant research team at Bloomberg. And very recently, it has graduated to become a community project. So if you were to click on this link here, it is no longer hosted on the Bloomberg public repository, public organization, but it has its own. Bqplot is now its own organization. So contributions are welcome if you like what you see. Bqplot is based on the grammar of graphics. The idea behind the grammar of graphics is that you can compose a plot by using the various subcomponents, such as the scales, the axes, any marks that you want to add, marks being lines, scatters, bars, etc., and finally a figure, and then sort of putting them all together. So Bqplot is inspired by that. However, with that said, it provides two APIs for you to create your plots. One is a pyplot-based API, and I say pyplot because it is inspired by matplotlib. I'm just importing everything here, and I'm creating some dummy data here. And next few cells will read familiar if you've done matplotlib, because the API is very similar. However, it is not identical. So Bqplot does not exactly mimic the pyplot API of matplotlib. So it is important that if you are looking to use this API, to use the Bqplot documentation and not matplotlib, because many of the methods and properties that matplotlib exposed are just simply not existent on the Bqplot variant. But with that said, it allows you to produce very good looking visualizations with relatively less lines of code. Now, one big difference between matplotlib and Bqplot is that Bqplot renders everything in the browser. Matplotlib has a kernel and it generates a static image. With Bqplot, the data that represents the plot is passed from the Python side and then rendered in the browser in a form of SVG elements. The result is that you can have this highly scalable, very fluid, dynamic, crisp visualization, which are interactive in nature. So I can sort of pivot this around, zoom in, zoom out, and that just comes out of the box because of the way these plots are rendered. Two more examples here of the pyplot interface. So this is just a scatter with a color bar to add another dimension to describe your data in a very, very simple histogram. But where Bqplot gets really, really powerful is with the object model architecture. And this is where you really see the grammar of graphics becoming more prevalent. So we are going to construct a line plot here, and we're going to start with two scales describing the data for both the Y and X domains, which will be linear, so linear scale. We're then going to create data to describe the two. We have two random walks describing the two separate paths, which we will represent as lines. We're then adding or creating a lines mark, which, as the name suggests, allows you to draw lines. Two axes, one for the X and one for the Y, and finally a figure. And then in the figure, we're referencing all these individual components. So like a line for the marks, you can have multiple marks, doesn't have to be one. And the axes, you can have multiple axes too. So you can have a left-hand side y-axis in addition to a right-hand side y-axis if you wanted. This is what it looks like. So as you'd expect, these are all widgets. So everything created above are widgets, the lines mark, the scales, the axes. So if you wanted to change the data on the fly, you can simply do so. So I'm going to access the Y property of my lines mark and just generate new random data for the two random walks. And I don't know if the video stream allows you to see the smoothness of the transition, but Bqplot updates in this really smooth fashion. So again, the data, we don't really redraw everything. The data just gets transported from the Python side to the browser, and the browser then D3 does its magic and sort of only draws the new lines. And you get the added benefit of animations. Now, some people may not like the animations. The idea behind the animations, and generally Bqplot, is that it is built for the Jupyter ecosystem, so it's highly interactive. But if you prefer something static, then you don't have to use animations. I can just set my animation duration here to 0, and then this will behave more in a matplotlib fashion, where things just update statically. Similar example, just with a scatter plot. So again, creating two linear scales, 2 axes, and a scatter mark this time, and a figure to host that scatter mark. Updating the data of the scatter mark. Again, as you'd expect, just updating the property, the X and Y properties, and everything shifts around. However, you don't really have to, I've only shown so far how to update the data properties of the lines mark, so the X and the Y, but remember, everything is a widget. So I can actually update the X scale. So this is a linear scale, and the range here has been inferred from the data, but I can say, actually, I want it to start at 4. So now it starts from 4. I can also change the X-axis label. Currently, it just displays the character X, but it can be anything else I want. And again, you can do this on the fly. Now, what we have seen so far is using data that you're generating from Python and then sending it to the browser side for Bqplot to render. But this is a two-way communication mechanism, so you can actually use Bqplot figures as inputs. And let me show you what I mean by that. So here's an example of a way you can interact with your plot. So let's say you have this plot here, and you are really interested in knowing what happened when these two lines intersected. So you can create this thing called an interval selector. And the interval selector, as the name suggests, allows you to create a range or an interval. And the width, or just how long that range is, depends on the vertical position of my mouse. So if I move it higher, it selects a wider range, and if I move it lower, it selects a more narrow range. And I can sort of lock this in place, and now I can actually access on the Python side the range of data that I have selected here. This is just for one of the lines, but you can see I'm somewhere around 53 all the way to 71. Again, simple example, but you could use this as an input. So let's say you would have some sort of widget that reacts to any of these ranges that are being selected, and then, create an additional plot or run some sort of computation. Another really cool feature, and another way that I think really authentic way to use Bqplot is to use its hand draw functionality. So again, we have some data here. You may be analyzing some data, and typically when you get raw data, it might be a bit rough to handle because you have some spikes, some missing data, etc. You could write a function to smoothen everything out, but if it's something really quick that you're just seeing on your chart and you think, I don't really want to go through the hassle of trying to modify the data from the Python side, you could just come here and say, I just want to hand draw this bit and smoothen it out. So you don't have to write like an extrapolation and interpolation functions for this. And that data will then be available for you, again, by just simply accessing the property. And you can also, if there is a function that you're not quite sure how to represent that function in a Python code yet, you can, again, if you know what that function looks like, you can just draw that function, and there you have it. You didn't have to write Python code for that. Okay, let me just check if there are any questions. Yes, Andres. Power is good. Power is good if used responsibly. And yes, Martin, we will skip ipyvolume. I understand we're a bit short for time. We will skip ipyvolume. I'm happy to sort of show this separately. Just ping me via the Slack channel, and I'm happy to walk you through it in a separate session. Okay. So there's one example here which is a bit more elaborate. So I'm going to jump straight to the example first, and then I'll explain what's going on. Hopefully you'll be able to infer from what's displaying on my screen what is about to happen. So we have actually two marks here. We have a scatter mark and a line mark. And the line mark reacts to the scatter mark by plotting the average of all these data points. So a very sophisticated example. But the nice thing is I can actually click directly on any of these data points and drag them around, and you can see that the average, the arithmetic mean here, updates as I drag them. So again, probably a more basic example, but another way that you can sort of see how Bqplot can then be used as an input, because based on how I am arranging what I have here and the line plot giving me an average, I can then use that in a separate widget, which in whichever way I see fit. So I'll just walk through what exactly, I'll just unpack some of the code here. This is self-contained, so I think you should be able to just copy paste this in a notebook or in a separate window, a Jupyter Lab window, and it should work. So we are just importing all the relevant Bqplot widgets here, NumPy to create some dummy data. This should be a familiar pattern by now. 2 linear scales for our X and Y axes, a scatter mark and a lines mark. There's a label mark here too, and the label mark is just this little text thing here that is displayed. And we have a callback function called update line, and you can see that we are we're following the observe pattern, and we are observing the X and Y properties of our scatter mark, and whenever any of these change, we call update line, and update line then recreates or updates the dashed average line, and also updates the label that I have with the exact numerical value. And yes, we have the axis and the figure, and then we are just displaying the figure. So the display function is quite useful if you want to define something which should render as the output of the cell, but you don't want to define it as the last line of code in the cell. Because typically what you would do otherwise is say, I want to just type figure here. Okay, this is it for the demo I have for Bqplot. I don't know if we have time for the exercises. I'll let my colleagues decide. We will skip ipyvolume, but as I mentioned, I'm happy to walk you through it later. Or you can just feel free to just read through it on your own. It's an awesome package. Team, do we have time for the Bqplot exercise, or do we want to move on? Okay, so yes, let's move on. If you are unable to complete this exercise and you're interested in doing it in your own time, ping me on the Slack channel and I'll send you the solution. Yeah, as I think what Matt suggests is another possibility. Just work on it in the meantime, and then we can pick this discussion up in the Slack channel. Martin, you are on the screen already, right?
Yes, I'm there. So,
fantastic.
Can you stop sharing your screen?
Stop now.
Thank you.
Thank you.
So I'm going to show you how to make a dashboard out of your notebook. So I've got this small notebook here on which I create two sliders, two widgets, sorry. I've got one slider and one text input, and I've got a pandas data frame that I display in the notebook. So I want to put this in a single page application. So you have one way of doing it, which is to use nbconvert. So if I use nbconvert, let me just check the name of the notebook. I can do Jupyter nbconvert to HTML and the name of my notebook. And I can choose if I put the cell inputs or not. And this, what it will do, it will create an HTML file that I can open with my browser. It's here. So, and the widgets don't work. That's unexpected. Okay. I don't understand why the widgets don't work. Maybe I'm missing an option. I don't know. That was not prepared. I thought about showing nbconvert at the beginning of the presentation and didn't think about testing it. But basically, nbconvert allows you to turn your notebook into an HTML page. But the thing is, if you do that, you should see widgets. I don't know why it was not working there. But because you have a static HTML page, the link between the two widgets would not work anymore. So in order to make them work, we need a Python kernel running on the server. So for that, we are working on a tool which is named Voila, which allows you to serve your cell outputs of the notebook into a web application and without the cell inputs. So the way it works is you just type Voila and the name of your notebook. And this will start a server, execute the notebook, the entire notebook. And then what I get all my widgets and all my cell outputs. And the Python kernel is still living. So I still have the messages that are sent to Python. So the links are still working. JS links are working. Observation is working. Everything is working. We also have a small Jupyter Lab extension here, which gives you a small button. And when you click on it, it will show you a preview of your dashboard. And if I do render, if I check render and save, and if I update this notebook, I save, update the dashboard automatically. So this is just to give you a preview of your dashboard. So technically, each notebook you have should be compatible with Voila. So you just type Voila, the name of your notebook, and it should work. The Bqplot notebook that Itai just showed, if I do Voila notebook 0703, it will execute the entire notebook and give me the outputs with all my plots. So, and the hand drawing is still working. So as you can see, it's not really pretty because it's basically a blank page and all the widgets are put one after the other on the page. In Voila, we have a way to provide templates. So if if you look for Voila templates online, you can find, for example, the Voila material template, which gives a material design look to the dashboard. And the way you use it, you just install it. So if I install it with Conda, it will be this. And then once it's installed, just voila your notebook and dash template equals the name of the template. And this will give a nicer look to my dashboard. So if you know a bit of JavaScript and CSS, you can actually implement your own templates. We did not write so much documentation about how to create your own template because we were not decided on the template API yet. But it's actually coming to the next release, and at this point we'll write a lot of documentation about how to create your own template, and it will be easier to I don't know, to put the logo of your company on top and create your template with your colors and everything you like. I've got another example here. So this example uses ipyvutify. So ipyvutify is a kind of a ipywidgets counterpart, but using the material design. So if I create a Bqplot plot here and a slider from ipyvutify, and if I create another plot and a small layout using ipyvutify, then what I can do, I can use the Vutify default template to execute this notebook. And I will get a very nice dashboard. It's responsive, so if you have a small screen, it will work on a tablet, for example. So this is very cool. And you cannot say when looking at this that this is a Jupyter notebook. It's coming actually from a Jupyter notebook, so only writing Python, you can do this. So yeah, I don't know if we've put the links to ipyvutify and the Vutify template, but you should definitely look at it. You've got material design for buttons, for sliders, you've got range sliders, drop downs. It looks super nice. And it's almost the same API as ipywidgets, and it's based on ipywidgets. And you have the Voila Vutify template for making a really nice dashboard out of ipyvutify. So I guess that's it. Yeah, I wanted to talk about deployment as well. So you can actually deploy your Voila application on Binder. And this is done by, so for example, I've got this small repository on which we have, so this is Martin Breddel's repository, and he has the exact same notebook I just showed you in a repository, and using Binder, I'll be able to deploy it. So if I go on my Binder and type the name of Martin's repo, and you can, so if you want Binder to render the notebook using Voila, you just need to do render Voila, like this, if I'm correct. Yes, voila render the name of the notebook, sorry. Just like the command line. So voila / render name of the notebook. And it was, sorry if I'm going too fast, it was this notebook. And if you do launch, it should build the repository and start the notebook using Binder. So this is one way of deploying your application online and share it with others. But you can also use Heroku to deploy your application. So if you look at the Voila documentation, you will actually find everything for deploying a Voila application. So we have some documentation for deploying to Heroku, and we've got some documentation for deploying to Google App Engine. And I guess that's it for me. I went a bit faster than I was supposed to. I thought we were out of time, but I guess if you have questions, please go ahead, and we have time for questions.
Yeah, so just a note, so we have about 9 minutes, and then the session will be cut off automatically.
Okay.
I have no control over that. So yeah, if you guys want to go through the questions in the Ask a Question thing and just address the ones that haven't been answered yet, I can knock those off.
Okay, let me have a look. So lots of them have been answered. I guess the new ones are the one on the bottom. If you look at the comments, all the questions were answered, it looks like. And maybe on the chat, there are more. Can this be deployed as a standalone web application in Chrome? Well, yes, you can deploy it using Heroku, and you can look at the documentation of Voila. Let me just push a link to this. And you'll find how to deploy them on Heroku and Google App Engine, and this will work on Chrome. So how did the layout work in the dashboard? So this is all using ipyvuetify and the Vuetify template. So if you look at the example notebook I executed, you will see the code, and you will see it's all using ipyvuetify. And in this library, you have lots of objects, objects for layouting and making tabs and making boxes and making layouts. Yes, and Grok is super nice for quickly deploying applications. So, yeah, thanks a lot, Mike. It was great. You did a great job. Did you guys wanted to show another notebook? Maybe I should show ipyvolume if we have 6 minutes. Let me just. So you still see my screen, right? So using ipyvolume, you can do 3D plotting in the Jupyter notebook, and you can do multi-volume rendering. So here I've got a scatter plot with 1,000,000 points, I think, in 3D. So it's pretty cool. You can save it to install an HTML page, and you have. Sorry. You have animations, just like in Bqplot. So if I change this, let's just create a view for this. have animations, you have lots of goodies in it. So here I have an animation on the color and an animation. Oh, yeah, it's here. Play button. So you can animate your 3D data super easy using widgets and ipyvolume. So there is no example for volume rendering. That's actually what I think is the coolest, but yeah, if you look at the repository, Martin Bredal's /ipyvolume, you will see a multi-volume rendering example. Cool. So I hope you enjoyed it as much as we did. It was a bit difficult with the lab extensions installation, but I guess we did it.
So there are 2 questions left in the question section that are, I don't know if they've been, oh, wait, no. Okay, so that one's been answered. And
So ipyvolume, it's browser side render.
browser side.
Yeah, it's WebGL.
All right, you're down to 0. Okay, do you guys want to conclude before we get automatically cut off?
Yeah, so if you have any questions, don't hesitate to come to the Slack or to come to the Gitter channel for ipywidgets. You can find a link to the Gitter channel in the README of the tutorial. And I hope you enjoyed it. It was great. Thank you for listening. Thank you for coming.
Yeah, and thank you guys for presenting. And then just a note for attendees. So the welcome and keynote is at 1:45 Central Time, followed, and then some more Q&As up through 5 o'clock Central Time, and then some breakout rooms from 5 to 6. So look for that. I will end the broadcast here. And thanks again, everybody. And hope you had a great SciPy.
Thanks a lot. Thanks.